For this practice, we're going to look and find the partial pressures and total pressure of a container that has the following: 11 grams of argon, 10.6 grams of dinitrogen, and 14.3 grams of dioxygen. It's 28 degrees Celsius, it's in a 1 liter container. Go ahead and pause, try to solve the partial pressures of each gas and the total pressure of the container. All right, well, what do we need to do for this one? Well, I've got a container, and it's going to have 3 different gases in it. And the weights aren't too far off, but gases aren't about weights, they're about moles. So I don't know if I have a whole bunch more of one of these, or if they're all fairly equal. First thing first, we need to determine how many moles of each gas we have. For argon, we have 11.0 grams of argon, and it is 39.95 grams per mole. So we have 0.2754 mole of argon. If we do that for dinitrogen, 10.6 grams, 28.0 grams per mole, for 0.37857 mole of dinitrogen. And if we want to do it for the O2, 14.3 grams of O2 at 32.00 grams per mole for 0.44687 mole of O2. So we have clearly fairly different numbers of each gas, but I have the moles of each of them, which gives us a couple options. I could calculate out the pressure of each individual gas. I know how many moles, I know it's at 28 Celsius, I know it's in 1 liter. I could calculate the pressure of that gas in that container at that temperature. We could then sum all those pressures and get the total pressure. Similarly, I know all the moles. I could just sum the moles and find the total pressure. If I want to sum the moles, N total, just the sum of all 3, we'll find there's 1.1008 mole of gases. So I can find the pressure total from that. P total is going to equal the moles total times R times temp over the volume. 1.1008. Let's do it in atmospheres. 0.08206 atmosphere liter mole Kelvin for our R value. My temperature, 28 plus 273.15 for 301.15 Kelvin, and a volume of 1.00 liters for a pressure total of 27.20 atmospheres to 3 sig figs. That's my pressure total. To find the partial pressure of each gas, remember that my pressure total times the mole fraction will equal the pressure of that gas. So I'd need mole fractions. Well, I have the moles of each gas and I have the total moles. A mole fraction is just what percent of the total moles is there. And so in our case, 27.2 atmospheres for pressure total times, let's do argon, 0.275 mole of argon over 1.1008 mole total. That's going to give us our mole fraction times the total pressure. And for argon, that's going to come out at 6.81 atmospheres. Similarly, we could do the same for our dinitrogen and our dioxygen. We know the moles for each of them. The calculation will still say the total pressure times their mole fraction, 0.44687 over 1.1008, 27.2 atmospheres swapped O2 and N2 here. 0.37857 for the N2 over 1.1008 total. To find that there is 9.36 atmospheres for dinitrogen and 11.05 atmospheres for dioxygen, we can find the individual partial pressures. So there's a couple ways to go about doing it. I could have done an ideal gas law for each equation using the moles they had, or I could combine the moles, find the mole fractions, and compare that mole fraction to the total pressure.